everyone, my name is Mark and I lead research at OpenAI. Yesterday, we took O1 out of preview and we launched it in ChatGPT. We're soon going to launch it in the API. If you haven't been following O1, it's our latest series of model improvements that allow the models to think for a while before they come back with a response. Today, we're really excited to preview our latest advancement in our model customization program. It'll let users fine-tune O1 on their own datasets. And again, this isn't standard fine-tuning. This is reinforcement fine-tuning, which really leverages the reinforcement learning algorithms that took us from advanced high school level to expert PhD level for your own use cases. I want to stress again that this is a preview of something that we're going to launch publicly next year. But if you are a university or you're a researcher or you're an enterprise, we'll give you some information on how you can access our alpha program later. So why would you want this thing? Well, it allows you to take your golden data sets and turn them into unique offerings that will give you the same magic that we have for your own users and your own customers. So I'll let John, Julie, and Justin say a little bit more.
Yeah, hello everyone. Yeah, my name is John Allard and I'm an engineer here at OpenAI.
Hi everyone, I'm Julie Wong. I'm a researcher here at OpenAI.
I'm Justin Reese. I'm a computational biologist at Berkeley Lab.
Today, we're so excited to be introducing this new way of model customization for our O1 series of models, reinforcement fine-tuning, or RFT for short. For the first time, developers, researchers, and machine learning engineers will be able to use reinforcement learning to create expert models capable of excelling at their specific tasks within their domain. We believe that any field which requires deep expertise in their AI models stands to benefit. So if you work in, say, legal, finance, engineering, insurance, this one's for you. For example, we recently partnered with Thomson Reuters to use reinforcement fine-tuning to fine-tune O1 Mini to be a legal assistant in their co-counsel AI. This tool assists their legal professionals in accomplishing some of their most analytical workflows.
Yeah, so some of you will be familiar with the supervised fine-tuning API that we launched early last year. And supervised fine-tuning is really powerful. What you're trying to do is get the model to replicate features that it finds in input text or images. And this is great if you want to change the tone or the style or the response format of the model. Now, with reinforcement fine-tuning, or reindeer enforcement fine-tuning, as I should say, with reinforcement fine-tuning, it's different. So you're not just teaching the model to mimic its inputs. What you're teaching it to do is to learn to reason in entirely new ways over custom domains. And the way this works is that when the model sees a problem, we give it space to think through the problem, and then we grade the final answer from the model. And then using the power of reinforcement learning, we reinforce lines of thinking that led to correct answers, and we disincentivize lines of thinking that led to incorrect answers. And what you'll see is that, with as little as a few dozen examples, the model will learn to reason in new and effective ways over custom domains.
That's crazy that you can do that with just 12 examples. That's not something you can do with regular fine-tuning.
Yeah, exactly. Yeah, I mean, in the space of large language models and large machine learning, a few dozen examples is basically nothing. Yeah, so for the first time, our model customization platform will support reinforcement learning. And notably, this is the same technique that we use internally at OpenAI to train our frontier models like GPT-4o and the O1 series.
One area with many exciting applications is scientific research. But don't just take our word for it. That's why we're joined today by Justin Reese. Justin is a researcher at Berkeley Lab, and one of his areas of study is using computational methods to understand the genetic causes underlying rare diseases. Justin, thank you so much for being here. Do you mind telling us a little bit more about your research and how reinforcement fine-tuning might help?
Sure, thanks. It's great to be here. So one of the areas of my research is rare genetic disease. So contrary to the name, rare genetic disease is actually not rare. So any one rare disease is rare, but if you put them all together, they're actually quite common. And so we're talking about 300 million people globally who suffer from a rare disease. And what's more, these people often have a long diagnostic odyssey of months to years before they find out about their condition.
Wow, it's like the whole population of the US.
Yes, it's not a small number of people. And so what we're working on is better computational tools and methods to really research what's important and to help us understand and treat these diseases. So we do our work in kind of an academic setting and learning more about the rare diseases and their causes. And the hope is we'll be able to advance the healthcare for these folks going down the line. And now, assessing rare disease is kind of hard because you kind of have to have two things. You have to have sort of expert domain knowledge about the medical side of things, and you also have to have sort of systematic reasoning over the biomedical data. And this is an area where we think that the O1 model can really help us out with its reasoning capabilities.
That makes a lot of sense. You know, our large language models have domain knowledge, and our O1 models are really systemic reasoners. So it seems like now there's a pretty good computational method for addressing some of these.
That's right.
Can you tell us a little bit more about the data sets that you're using?
Sure. So this was sort of a collaborative effort between our group and Charité Hospital in Germany and Peter Robinson's lab and the Monarch Initiative. And what we did really was to extract disease information from hundreds of scientific publications that were case reports about rare disease. And so we sort of curated the information, and that's lists of signs and symptoms that were present in the patient and that were excluded in the patient, and then of course the disease that they had, and importantly for this conversation, the causative gene that was mutated that was causing the problems in these folks.
I see. So you and maybe some doctors are trying to figure out, given a patient's symptoms, what gene might have mutated to cause those symptoms.
Yeah, that's right. And so something we've been working on together with the OpenAI team is training the O1 models to reason more effectively about the causes of disease.
Incredible. Thank you, Justin. We're now going to give you a preview of reinforcement fine-tuning at work. And not to steal any thunder, but we're going to take O1 Mini and make it exceed the performance of O1 on this task. That's the O1 that we just launched yesterday. And this matters so much because O1 Mini is a smaller, faster, and cheaper model than O1.
Yeah, so using Justin's data set, we're going to show you can just drastically improve the performance of O1 Mini on this task where, given a list of symptoms, you're trying to predict which gene might be responsible for the genetic disease. And so to give an overview of this process, we're going to start by looking at data sets that are used to train the model and graders that are used to evaluate the model. And then we're going to launch a training job on OpenAI's training infrastructure. And finally, we'll evaluate the resulting fine-tuned model so we can see how it's improved over the base model that we started with. So to start us off, we're going to jump over to the OpenAI development platform, and we're going to go ahead and we're going to create a new model. So we've had supervised fine-tuning for a bit over a year now. What we're going to do is we're going to select reinforcement fine-tuning. Now, we're going to be training O1, so we'll select that as the base model. And now we need to upload a training data set. And now, training data sets, they're just JSON-L files, which is just a file where each line in the file is an example that you want the model to be trained on. For this case, Justin and his colleagues assembled a data set of about 1,100 examples. And so I'll go ahead and upload that one. And just so that we get a really good feel for how this data set works and what this task is, we'll zoom in on an individual data point really quickly. And so this is what an individual data point looks like. And there's really three important things here. So the first is the case report. And this is a description of the patient and the patient's symptoms. So we see that the patient was a 51-year-old woman. The disease onset was not specified. We have a list of symptoms like hypertelorism, hyperparathyroidism, and others. As Justin said earlier, we have the absent symptoms. These are the symptoms that are not present. And this is important because it helps the model to rule out genes that it might think would otherwise be responsible for these symptoms that are present. Next, we have the instructions. And I'm sure if you're watching this live stream, you're familiar with prompting. And so all we're doing here is just prompting the model for what we want it to do for this task. And so what we're saying is, given the list of symptoms and the case report, can you list all the genes that you think might be responsible for the genetic disease that you think is present? And then we also ask it to provide an explanation for why it thinks those genes might be responsible. Finally, we also have the correct answer. And so this is the gene that we happen to know is responsible, but importantly, we're not showing this to the model during the training process. That would be cheating. But we're using it internally during the training process to grade the model's outputs or to check if the model's correct.
This is a pretty hard task. I definitely have no hope of answering this question.
Yeah, I mean, you can tell that we've come up far away from just trying to count the number of R's in the word strawberry. Yeah. So, now when we give the model this prompt, this case report and these instructions, the model's going to output something like this, which is a list of genes that it thinks might be responsible. And importantly, the genes are in sorted order, where the first gene in the list is the one that it thinks is most likely to be responsible, the second one in the list is the one that it thinks is second most likely, and so on and so forth. Cool. So we'll hop back over. And so next we need to upload some validation data. And validation data, it's going to be in the exact same format as the training data. But importantly, there's no overlap in the correct genes between the validation data set and the training data set. And what that means is that the model can't cheat. It has to, or it can't learn to just memorize a list of symptoms and associate those with the gene. It has to actually generalize from the training data set to the validation data set.
Gotcha. So, I mean, where's the reinforcement part come in? You know, we talked about grading. Is that part of the process here?
Yeah, that's a really good question. So grading is done by this concept of graders that we're introducing here. And so graders are really simple. What a grader does is it takes the output from the model, and it takes the correct answer, and it compares them, and it returns a score between 0 and 1. And so 0 means that the model did not get the answer correct at all, and 1 means the model got the answer correct. And you can also give partial credit, so it can be anywhere in that range. So for this specific task, we have a grader that looks like this. So it takes the correct answer that we happen to know, and it takes the output from the model, which is the list of genes, and it produces a score. So in this case, you know, FOXY3 is the correct answer. It was second in the list of genes, and so it gets a score of like 0.7.
I see. So if it had instead said FOXY3 was first in the list, I would have gotten a grade of 1?
Yeah, exactly. Nice. And then as it gets further and further along the list, the score kind of gradually decays to 0.
Nice. Makes sense. But what if I have a task that isn't, you know, grading a ranked list? Do we have other graders that are more general?
Yeah. So we're supplying kind of a collection of graders that we think pretty effectively cover the space of possible intents that you might have for while doing reinforcement fine-tuning, and we're always adding more.
Yeah, and eventually we're gonna hopefully let you define your own graders.
Yeah, maybe like upload a Python file or something and do some custom grading. Yeah. Cool. So we've defined our training data set. We've defined our validation data set. Let me go ahead and copy in the grader really quick. And now OpenAI allows you to set, we allow you to customize these fine-tuning runs by setting hyperparameters, but we set some pretty good defaults. So I'm just going to go ahead and click Create here. Now, what this is doing is, we've just kicked off a training job. And so the really cool thing is that you bring the data set and you bring the grader, and these are the places where you really have domain expertise and where you can really contribute to this problem. And then you get to leverage the full power of OpenAI's reinforcement learning algorithms and our full distributed model training stack to customize a frontier model for your use case.
So as a user, I just have to bring my data set and the grader, and OpenAI takes care of everything else.
Yeah, exactly. Yeah. Reinforcement fine-tuning jobs can take anywhere from a few hours to a few days to run. So we're going to jump over to a job that I ran earlier this week on the same data set, just so we can kind of see the results. So I'll jump over here. So I had this job that I ran earlier this week. It completed successfully. It produced a fine-tuned model for us. And there's one thing that I want to look at, which is the validation reward score. And so what this is it's the average score from the grader on the validation data set and how it changed over the course of the fine-tuning run. And so what we can see is that the score is going up. And as we said earlier, since there's no overlap in genes between the training data set and the validation data set, it means that the model really learned to generalize on our task. It wasn't simply memorizing a list of symptoms and mapping those to genes. So, while this is cool, the chart goes up and to the right, which is what we like to see, it'd be nice if we could get a better feel for how the model has actually changed during the fine-tuning process. And so, we'll take a closer look at that now.
All right, so we're going to pop over to the evaluations dashboard, which is a product in our developer platform that we launched earlier this year. There's a lot of numbers, but don't worry, we're going to go through all of them. So I've set up 3 different runs here. The first one was a run against our O1 model, which we released yesterday. The second was against O1 Mini, which was the starting point of our fine-tuning job. And then finally, the reinforcement fine-tuned O1 Mini. Now, we looked at the reward going up and to the right, but what does that actually mean for this task? I've set up 3 different evaluations to sort of assess that. The first one is top at 1, which is how often is the correct answer the very first item in the list. Top at 5, which is how often is the correct answer in the top 5 elements of the list. And finally, top at max, did we at all put the right answer in our list? And so looking at top at 1, we can see that our starting point, O1 Mini, got 17%. On our data set of about 200. O1 got 25%, so it's doing better. But then our fine-tuned O1 Mini got 31%.
Awesome.
I took a screenshot of this and I put it into ChatGPT and asked it to make me a plot, a Christmas-themed plot. And here's a nice visualization of those 9 numbers that we saw earlier. So you can see our starting point, O1 mini, across top at 1, top at 5, and top at max. Our O1 model, and then finally our best performing model, which is this O1 mini fine-tune here in dotted red line. So looking at these results, what do you think, Justin?
Well, I think this is pretty impressive performance, and especially the increase in the validation data, because that implies that the model is learning something generally about how to reason over these kind of data, which is pretty exciting. And so an obvious question you might ask is, how is this doing compared to existing bioinformatics tools? And I don't really have an apples-to-apples comparison, but because typically in this kind of experiment you would provide genomic sequencing data, and we haven't included that here. But the sort of open-ended querying of models here over incomplete symptom lists is new and exciting, I think.
Great. So these are aggregate statistics, but let's look at the actual model responses. So I'm going to pop on over to this data tab. Let's filter by the passes. And so here is the input that we're giving to the model. So the problem, as John described earlier, is to identify genes that may be responsible for a set of observed symptoms. We asked the model to output a dictionary containing both a string that explains, why did I pick these genes, and of course the genes themselves in ranked order. And then finally, we have the symptom list as well. So this patient presented with subependymal nodules, seizure, and a couple other things. We then run our models. So this was our O1 model. This was our fine-tuned O1 mini model. We gave it that input. And now the output is this dictionary that we described earlier. So reasoning, the combination of subependymal nodules, seizure, cortical tubulars are indicative of this complex, which is commonly caused by mutations in these genes. It lists a couple other potential ones, and then it says TSC2 is the most likely candidate. And if we scroll back on over to our answer, we'll see that TSC2 is in fact the correct answer. So that allowed us to get a pass on top at 1, top at 5, and top at max. So looking at this output, Justin, is this a useful output for the model to be giving back?
Yeah, absolutely. So it's particularly useful to see the model's reasoning, and that's a big contribution here. And also obviously the ranked list of answers. So even if the correct answer is not first, you can look at all the possibilities. And it's also great to see the fine tuning improves the performance in the ranked list of possible answers, so that right answer is getting closer to 1. So that's gratifying.
Justin, kind of zooming out a little bit, how does reinforcement learning shape your field? Can you talk about some trends in biology?
Sure. So I think there's a lot of interest in the research community in using these models for these kind of tasks. And so the feeling for this particular use case is that the best solution in the near term is probably a hybrid solution between existing bioinformatics tools and these models like O1. And so this, I think, is excellent progress in sort of characterizing the strengths of these models and also how we can use tools like fine-tuning to improve performance. And so, like I said, there's not really a comparable benchmark to compare the two, but it's definitely progress in how we can use these models to kind of understand disease. And then, in a larger sense, to sort of how we can incorporate these models into a workflow that will eventually improve healthcare for these folks.
Right.
Amazing. Thank you, Justin. So while we've just shown you an exciting application of reinforcement fine-tuning in scientific research, this is a general purpose technique. We've seen promising results in data sets from biochem, from AI safety, from legal, and from healthcare as well. We can think of hundreds of more examples or tasks that we can use this model on, but we know that you can probably think of many more. So that's why we're so excited to be expanding our Alpha program today to enable more people to push the boundaries of the capabilities of our O1 models on the tasks that matter the most to them.
Yeah, so we've been working with a small group of trusted partners to really test out reinforcement fine-tuning. And today we're expanding alpha access via what we're calling the Reinforcement Fine-Tuning Research Program. So this program is ideal for organizations who are currently working on very complex tasks with teams of experts and who think that they might benefit from AI assistance on these tasks. So if you're interested in applying for one of these limited spots, you can find a link to the application in the description of this live stream. And as Mark said earlier, we plan on launching this product, Reinforcement Fine-Tuning, publicly early next year.
Yeah, we're all really truly excited to see what you do with reinforcement fine-tuning. And really speaking as a researcher, there's nothing that makes us happier than seeing our models being adapted and used to advance science knowledge in the real world. Do you have a joke for us today?
Well, as so happens, I do. As it's become tradition, I have a Christmas-themed joke. So, we live in San Francisco. Self-driving vehicles are all the rage.
Okay.
And actually, Santa's been trying to get in on this, too. He's trying to make a self-driving sleigh, but for some reason, his models just keep not identifying trees, and the sleigh is hitting trees left and right. Do you guys have any guesses why?
No.
He didn't fine-tune his models.
Oh, geez. Okay, all right. Please join us next week. We'll have a lot more to share. Thank you.
All right, so that joke was so bad it ended the stream. So what did we all think about this? Definitely it sounds like it's more for specific use cases. It is really interesting to me that they specifically used kind of like the genomics space, gene sequencing and trying to figure out what different mutations and genes kind of contribute to what diseases or functions in the body. So sort of the genomic space and the proteomic space, right? What AlphaFold is doing is incredibly interesting to me. It's so weird because every once in a while people will say, turn the mic back on, and I don't know if they're trolling or not. Can you guys hear me? And how's the volume here? All right. All right. Audio's fine. Mic is low, good volume. Yes, yes, yes. Okay, cool. There's a bit of a delay, so fine tune my. Yes, I wonder if this model will be able to fine tune my microphone audio volume. Yeah, unfortunately, the OpenAI side, the volume was a little bit low, unfortunately. So let's see. Let me do this. Okay, so I noticed a couple of people talking about genomics in the chat, also talking about potentially, the kind of the longevity escape velocity, which is a fascinating concept. I first heard of it. What was the guy's name? Aubrey de Grey, I think was his name. So the idea of negligible senescence, senescence as in like the aging of our cells or our bodies or our organs, etc. And negligible meaning like it's so slow, it's so slight that it's not even noticeable. So if we are progressing, the science of healthcare forward, at what point does a person that's alive today, at what point do we reach the sort of the point where, let's say you're you expect to live till 74, but our science improves that expectant rate by 2 years for every 1 year that passes. That would sort of be a kind of the longevity escape velocity, because you're not immortal, right? You can still get hit by a bus or whatever, but you're expected that the progress will improve faster than your aging. So our ability to sort of fix the problems that are wrong with us are improving faster than how we age. Let's see, how's that? Is that better? And so some people are saying that, one of the reasons that they might be doing this is they want to get the unpublished data from the researchers out there. Because if you're researching into, let's say the genomic space, gene editing, whatever, and you want to fine tune a model, you have to upload your data. You might have to upload your data to get the fine tuned model. So maybe that's a way for them to get kind of the unpublished data. I don't think I've heard them say that they're not going to be training on that data. I don't know if that's the case or not. And I feel like a lot of people maybe don't even perhaps believe it if they say it. So who knows? So maybe, certainly this would benefit them as well if they're training on that data. If people are uploading their own data basically for free. But yeah, so kind of the intersection of, so Air Sand Fire, thank you for the super chat. Where's the $2,000 a month tier? I wanted a $2,000 a month tier. I feel like if they do unlimited Sora, unlimited all of this stuff, eventually it's gonna get to the point where you're gonna have a $2,000 a month tier. If you're running an app using the API and you're using it pretty heavily, I'm sure that could get into, unlimited amounts of money. You can blow through unlimited amounts of cash on there. Yeah, Debugger says, aging, I'm worrying about being poor. So I feel like hopefully, like the promise of AI, what a lot of us sort of believe it could do is eliminate a lot of the sort of scarcity, right? So with resources, with access to healthcare, et cetera. What happens if our healthcare starts, the price starts dropping drastically, right? Just kind of like the Moore's law, for example, with the cost of gene sequencing, like the price for that. So gene sequencing is sort of basically our ability to read the genetic data. So if we're able to take a sample of our DNA, the ability to kind of like put that into a readable format, right? So we can study it, so we can manipulate it, etc. Back in like 2000, in the early 2000s, I think it was. I think it was like hundreds of millions or like a billion or some insane to sequence one person's DNA. And now recently we're approaching the time where I think we actually went past, it's now cheaper than $100 to sequence one person's DNA. And so companies like Illumina, for example, are doing a lot of work in that space. Peter Thiel launched a competitor called Ultima that is also trying to do a lot of work in that space. I'm not sure how they're doing, but there's a lot of kind of effort to attack that space and solve the problems in that space, because AI is sort of naturally a really good tool to kind of unleash, because we have so much data in the genomic space. If we're able to sort of use the AI to gather the insights and figure out how stuff works, similar to how AlphaFold did it for the proteomic space, for protein folding. And now with AlphaProteo, they're actually beginning to design custom proteins, which, if proteins are kind of like the building blocks of life, they make all of our functionality, every function of life work, and we're able to like program that. Like we're basically programming life, which seems like it could be unlimited. Like what's the, sort of the ceiling for being able to program life? What can't we do? Maybe can we figure out like regeneration? Can we figure out immortality, longevity, whatever? It seems like there should be no limit. Demis Hassabis himself, so the founder of Google DeepMind, the CEO, so he's saying, he said that he believes we can eliminate disease in the next 10 to 20 years. He said in the next 1 or 2 decades, we can eliminate disease. And he's not a person that's kind of prone to hyperbole. He seems like kind of a very reserved person, like very scientific. So when he says something like that, and he's the guy that's in the thick, he's the one that got the Nobel Peace Prize with another coworker for his work in, protein folding, etc. So one second. Let me type. Why are you spamming the chat? You're saying you're the same person from yesterday. Why? Anyways, so the point being is, it seems like there's no sort of at what point do we run out of stuff to edit if we're able to edit the functions of proteins? And the other sort of topic we've covered is the other company, I think it was Evolutionary Scale, ES3 or ESM, the model was, are able to discover new proteins with specific functionality not seen in nature. So, Nobel Prize for Chemistry. Yes, it was in the. Oh yeah, I apologize if I said the Peace Prize. Yeah, it was in chemistry. Yeah. So, which is interesting because we're getting to the point where sort of the models themselves are, winning, making the progress, and the sort of the builders of those models are getting prizes for those categories. So, if Demi Sasabis is getting a prize for his contributions to chemistry, that he's not a chemist, right? He's a computer science background. So it's kind of interesting. Like, at one point do we reach the point where every category is basically the progress is driven by AI models, and the computer scientists behind those AI models start getting the awards for whether that's chemistry or physics or whatever else is the case. Let's see. Demi is by far the most likable person in AI, says the remarkable. And you know what? I think so. That I think about it. Like, I don't think there's a single person that's that's more likable than Demi Sasabis. He's just like, I don't think there's anyone that has anything negative to say about him. So yeah. In terms of the escape velocity, I think there are people, the longevity escape velocity. So I think there's people that are alive today that could live to see, whatever sort of hundreds of years of healthy lifespan. At this point, I think it's not unlikely. Obviously, in a couple of years, we might find out that there's some sort of a set point, some sort of a wall that we hit. But so far, it seems like maybe not. We keep kind of pushing forward, and we kind of seeing that we can solve some of these issues. So as AI gets applied to genomics, proteomics, all of this stuff, I don't know. Is there going to be a limit to how far we can take that? I mean, it would be sad if there is, but it's almost kind of scary if there isn't, right? If you think about that, like, what if we can code proteins and genes and stuff like that, and basically program life in the same way that we can program computers and software and whatever? What does that mean, right? Like, that seems kind of scary, as well as a lot of people have pointed out. That's basically playing God, right? So it's basically creating life in a way, or not from scratch, but with learning how certain existing codes of life work, and kind of like, similar to how you would pull blocks of code off of GitHub or whatever from somebody else's program. You sort of like, oh, I like this function and this function, and let's put it all together and see if we can kind of make it work. Like, what if in 5 to 10 years we get wetware? Yeah, exactly. Like, what if we're able to create biological life just like we create computers and hardware, etc.? The founder of NVIDIA, Jensen Huang, is talking about that. So he's saying, like, in biological sciences, we used to have the sort of, up until now, it was like discovery, right? We discovered new proteins and functions. We discovered new life. We discovered new things. And we're now beginning to enter engineering, sort of the age of engineering life, like building custom life, building certain biological functions on demand almost, which is crazy. Anthony Wexford is saying it's gonna happen using CRISPR and AI. I agree. So recently, the one of the founders of CRISPR were talking about how that Cas9 protein or something like that, one of the limitations with So CRISPR is, I might not be explaining this 100% correctly, but it's basically a gene editing approach that seems to be having a lot of potential, right? So it comes in and kind of snips a section of the gene, and we're able to like edit it and replace it. So it's kind of like, it's gene editing basically, right? So cut, copy, and paste, and it's using the Cas9 protein to do some of those functionalities. And my understanding, based on what she's saying, is there is a problem with how big that protein is, and that creates certain sort of inaccuracies sometimes, or certain complications. And at the time, this was shortly after the AGI, Google DeepMind released their paper on alpha proteome. And I couldn't help but think that this seems like this might be a huge solution to what CRISPR, one of their stumbling blocks, right? What happens if we're able to design these custom proteins without the limitations of, whatever, like you want something that has this function, but you want it smaller? No problem. Here it is. Like, what happens then? We're able to design proteins to customize our genes in whatever way, with perfect accuracy. That might not be that far away. That might be pretty close, actually. So I don't know. It's hard not to get excited. I don't want to be too like hyperbolic with this stuff, because again, who knows? Again, next year we might hit a wall, right? There might be like, oh, we didn't know this thing existed, and this thing means that, we just can't really progress in that area too much. But I feel like what Sam Altman was saying yesterday, or in an interview he did with the New York Times a few days ago, he was saying it's like, you see that sort of exponential curve of progress. Are you going to bet against that? Are you going to be betting against the exponential progress curve? I wouldn't, you know what I mean? Certainly. So Adrian Bargiel is saying, we'll hit longevity escape velocity, but when? I mean, I think that if you're 20 and under, I think there's a high chance you will hit that at some point in your life. I think if you're in your 60s and 70s, maybe that's not enough time. And if you're 30s, 40s, 50s, I don't know, coin toss, maybe, right? So 50-50. That would be my best guess. But I don't know if I necessarily have specific sort of data to back that up. Again, somebody like Demis Hassabis is saying, hey, we can cure disease in 10 to 20 years, right? So that's, so if you're 20, let's say by the time you're 40, we're able to get rid of a lot of like the disease that's happening at the cellular level. I think with Audrey DeGray, he said there's sort of like, I forget, maybe 4 or 5 things he's saying that this is the stuff that basically kills us. There's cancer, there's like plaque buildup, there's, I forget what the things were, but he's saying basically like, hey, if we can fix sort of these 3 key areas, we're going to be 80% of the way there, right? And a lot of the stuff is kind of like the Pareto principle, the 80-20, right? So 20% of the inputs contribute to, 80% of the outputs, so to speak. So, yes, somebody's saying immortal jellies and water bears. Yeah, exactly. Dude, water bears are like freaks of nature. What are they called? So water bears kind of like the not that the real name. I'm blanking on what they're actually called. Can somebody put in the chat, what are the water bears? What's the actual name for those little animals? But yeah, like you can launch them into space. They freeze, and then you bring them back, and then they thaw, and they're running around again. It's tardigrades, right? Tardigrade. Boom. There you go. Yes, and then there's the immortal jellyfish that seem to like grow older, so they go through all their life cycles of this, and then they like are like reborn almost, and they become like a kid again, or like they go back to their infant stage. So I don't know. I mean, certainly we have the template for all that stuff. Greg Brockman recently said he was working with research to train AI on DNA. That I haven't heard that, but it would make sense to me. It would be amazing to me. And certainly, it's funny. Somebody was sort of saying that maybe one of the reasons that Greg Brockman, who is one of the co-founders of OpenAI, I think the president, right? So he took like a leave of absence. And somebody was saying now that OpenAI is getting much more closer to sort of like whatever you want to call it, the U.S. government, the deep state, or whatever you want to call it, sort of like the machinery that's making stuff happen behind the scenes. Leopold Aschenbrenner in his paper, Situational Awareness, is saying, hey, this is going to be like the Manhattan Project, like the development of the nuclear bomb. This is going to be a government project, right? This is not going to be some like hippie AI lab over there in the Bay Area, you know what I mean? Just like, oh yeah, we're building ASI, super intelligence here. That's not how that's going to work, right? The sort of the national security apparatus of all these nations is going to be waking up to it. But they were saying that maybe sort of as OpenAI and the overlap between the national security apparatus of US, they're overlapping. I mean, you've seen the ex-director of the NSA now sitting on the board of OpenAI, right? Sam Altman's flying to DC to give various presentations. More and more people are talking, Eric Schmidt, the ex-Google CEO, is talking more and more about that here. Like, hey, there's like this conflict potentially with China. There's like this potential sort of arms race when it comes to AI, and US is not trying to prevent export of certain NVIDIA chips to China. So there's this like competition going on. So they're saying that potentially, certainly when you're working in those kinds of environments, you have to get certain clearances, right? So they're saying maybe one of the reasons that Greg Brockman was forced to like take a few months off was, because they had to like clear him into some stuff, or they had to do the background check or something like that. I don't know if that's true or not, but certainly, I think it's possible that maybe when they were starting to do this, it was just another AI startup or just another startup in the Silicon Valley. And now it's more like, wait, like, no, we can't just have whoever building these things that could be dangerous weapons, etc. But the point with that is I do hope that hopefully, how should I say this? So I think the US, sort of like the machinery behind the scenes that we can't see, they do kind of go out of their way to protect US interests. And by, whatever it means necessary. So if AI is a priority, whatever else happens, I think that there's going to be a lot of resources and attention paid to it. So I feel like whatever sort of, this is true for DeepMind. I think this is true for OpenAI. Certainly, with Elon Musk now being in a position of power, I think they just announced that David Sachs from the All In podcast is now going to be the White House AI czar, which certainly seems like maybe. Have you guys hear anything about that? Did you hear about David Sachs? So he was one of the hosts on the All In podcast, becoming sort of the White House representative, the czar on AI and technology. What do you think about that? Good, bad? I'm curious what people's takes on that is. Certainly, I'm kind of happy that they're putting somebody that has a background in AI, that sort of at the very least like follows it and knows about it to lead the nation or like the White House to help with that stuff. So that's certainly a good idea. It seems to me. I don't know too much about David Sachs, but I know that he's obviously, if they're building on stuff and they're investing in all that stuff, I mean, they're really connected in Silicon Valley and all that stuff. So seems like it's a good idea. So Shane is saying, I'm mostly excited for in the next 5 to 10 years to get super psychedelic alien type of insights from AI. one of the craziest things to me was listening to Andre Karpathy talking about how he's like, so he had a interview with Lex Friedman, and it's like 3 hours long, like most of those interviews are. And this is like 2.5 hours in, when I think, you know how some people get part of the good thing about having those long form podcasts, towards the end, people get tired a little bit. They kind of let their guard down. So they just say, it's more like honest and truthful. You can't just have your talking points. At some point you start kind of breaking down and having to be more, just say out loud what you're thinking. And so he's saying how, like, if there is a creator and this is like a simulation, then AI might be the thing that allows us to kind of like solve the puzzle of the universe and communicate to the creator that we're intelligent and we can exist, etc. And that was kind of mind-blowing, because I mean, Andre Karpathy is sort of, he's up there with Ilya Sutskever and Demis Hassabis and all these people in terms of his contributions to AI. So he worked with Elon Musk on the full self-driving cars at Tesla. Obviously, one of the very early people at OpenAI, right? I mean, this is somebody that's like there from the beginning. So let me see. Did I miss anything? Yeah, so Sahil P is saying, I think biotech is bigger than computer science. It's the next big thing, synthetic life for all purposes. I think every single person that's one of these sort of AI insiders, so Demis said that, Sam Altman said that, Jensen Huang said that. I feel like every single person that's at the cutting edge of this stuff, that's seeing where this is going, they're like health or biotech, biological sciences, etc. And I agree. The sort of the breakthroughs that we've been having in that space are kind of insane, and I think we're going to see a rapid acceleration. Earlier, somebody said, is healthcare, is it expensive because of, I forgot how you phrased it. Is there really scarcity or whatever? And the thing is, yeah. So I don't know how it is around the world. Certainly in the U.S., I feel like bureaucracy and inefficiency and all this stuff is probably driving, and just how everything's structured, right, is driving up the cost of healthcare much more expensive. We're getting less for the amount of money that we pay for it. So there's that kind of like structural component. But I feel like, imagine having some sort of an AI assistant that tracks all of your vitals, that has access to your DNA, your specific genome with your specific mutations and whatnot. Like, for example, I know I have the MTHFR mutation that a lot of people have. Well, it's like, I think like 10% of the population or something like that. And so that means there's certain things that I have to do, like it has to do with the methylation process, right? So if you have that mutation, there's certain things that are harder for you, and you have to avoid certain things. Like, for example, I buy Thorne vitamins from the company Thorne, that are the B vitamins that are like methylated, 5-HTP or something like that. I forget exactly what they're called. Forgot the actual name. But the point is, like, you're supposed to avoid folic acid, which is the synthetic version of folate that they put into everything. Like, anything you eat is going to have that stuff in it, and it's not good. Hey, Dylan Curious. Hey, what's going on, man? Dylan saying, what message should we send to our simulation creators if AI lets us communicate? What was that cheat code for Doom back in the days? IDQD? That. I want that. Immortality. Well, I don't know. At least, I don't know if we're close. So how Andre Karpathy was saying that is like, we're going to build the sort of the first AIs, like say that's tier 1. And then tier 1's going to build tier 2 or whatever. And so eventually, hopefully, as we kind of like rise up those ranks, we'll get to the point where whatever tier of AI is building the next tier of AI, that's the one that's actually going to, like, if there is some mystery to the universe and some sort of a bigger point to all of that, that's the thing that might sort of like give us a glimpse into that. But yeah, I mean, if you think about it, like imagine creating like a really complex games of Sims, right? Where you have all these various like things running around, they're living their lives. And it might even seem like it's some sort of like intelligence forming. But so Andre Karpathy was saying is like, it's possible to like, what would show that we were able to like break out of it? It would be to figure out the code of that video game and then like be able to like run your code on top of it. So I mean, if you're, let's say, playing a game of Sims, and then one of the little characters in there gets so smart and figures out how to run some function on your computer, right? This video game thing like hijacks your computer. Certainly that would show you that, okay, there's something going on there. Let's look into this a little bit more. Dylan Curious is saying, what if our reality has a cheat code or Easter eggs? This is getting crazy. The whole Easter egg thing, I mean, certainly when you talk to people that are talking about this potentially being a simulation, certainly feels like there's Easter eggs, right? That whole double slit experiment is a little bit weird. And I know some people get a little frustrated when I talk about that because maybe it's, I mean, there seems to be some weirdness that happens in the way that things are built. And then there's the whole idea of the fine tuning of the universe, right? Of the place that we live. They're saying how there's certain like gravitational constants and stuff like that have to be precisely what they are. Otherwise no life could exist, right? So if it's supposed to be 3, right? If it's a little bit higher, nothing could form. Planets in the universe couldn't form. If it was a little bit lower, nothing would form. And it has to be this particular number. And that's exactly what it is in our universe. So it's like, I don't know, is that an Easter egg? Maybe. If not, it's a heck of a coincidence. You know what I mean? Yeah, so that's definitely like a fascinating thing to think about. Because certainly as we build AIs to a better level, they're better able to create entire worlds, entire like universes, and populate them with what appears to be conscious, sentient being potentially, right? Or at least have like when you look at some of the stuff that's powered by ChatGPT, like the social simulacra experiment, right, where 25 little ChatGPTs, they run their own city. Like that seems like a very lifelike, very credible sort of simulation of the human experience. So, I mean, what happens is if within the next few decades we create something that resembles our universe with little things running around them that resemble us and how we think, etc. At that point, we have to kind of admit that, yeah, so since we can ourselves create these simulations, what's the chance that the thing that we live in, is not the base reality, right? We assume it is, but if we're able to create it, and then maybe eventually we'll reach the point where that simulation can create their own sub-realities, which that's the episode in Rick and Morty that I think is my favorite. If you've never seen Rick and Morty, the one with the simulations, I think is the one to start with. I think that's one of the best ones. Anyways, so yeah, so Marcelo Mato saying, hi from Brazil. I think that if one day we managed to simulate a reality, statistically speaking, it would be certain that it wouldn't be the first one, and therefore we're already living in one. Yeah, I think that was Elon Musk's argument. He's saying it's like, what's the chance of this, the odds are against this being base reality. And then, who was it? Somebody else was making the argument. It was like, well, since we don't have simulations, maybe not, right? It could be just like 50-50. Maybe we're like the first simulation or whatever, or we're the base reality. But as soon as we sort of build the first simulation, that would certainly show that, yeah, so it's possible. And especially if that simulation could reach a level of complexity to build their own simulation, like at that point, you're like, all right, this really could indicate that we are not in base reality, or at the very least that it's statistically improbable that we are. I mean, that's the argument at least, and I don't really see any logical counter argument to that. You know what I mean? Yeah, the problem with so Pigeon's saying the problem with the base reality argument is if there's infinite real universes, two, then it's infinite versus infinite, therefore 50-50. Yeah, I'm curious if, if you're building a simulation, do you not, just for statistical purposes, build like an infinite or some large amounts of simulations to see what's available, to have all the possible sort of things that can form. Sahil P saying you should do live streams more often. Also, I think AGI cannot be, so thank you. I also think AGI cannot be achieved without quantum computers based on the Orch theory or theory by Sir Roger Penrose. I really want to dig deeper into the Sir Roger Penrose theory. So my understanding, and I apologize, so I haven't done a full deep dive into it, but if I understand correctly, he's saying that our consciousness cannot be explained within sort of traditional computing, classical physics or whatever, that there's some sort of a quantum something happening to fully explain how we think, how we perceive reality, etc., which is similar to, so basically like our consciousness is not fully situated within the classic, what we think of as like this reality, classical physics. There's some part of it that's like almost outside of it. I hope I'm explaining that correctly. But the remarkable Anna saying Scott Aronson was debunking Penrose on Win-Win podcast. So I didn't see that one. I'd be curious to know what Scott Aronson thinks about that. During one of the speeches, he said, he's like, there's some things that I agree with Penrose on. So there's some overlap where he's willing to admit that Penrose had a point. But that whole rabbit hole is so fascinating to me, because it's like we're approaching the point where we're building these artificial intelligences. We're learning more about our own consciousness, and it's definitely like overlapping, right? So, Penrose, he's talking about like how intelligence and consciousness could be somehow intertwined with like quantum physics somehow. So I know it's not quite about AI. It's kind of like one step removed, but man, it's kind of in the same ballpark, and it's really, I think, bringing up a lot of questions about who we are and what intelligence is. One of the craziest things to me that I've heard, for example, that said was Sam Altman was, I think, that stated that he's saying that intelligence seems to be just kind of like an emerging thing out of physics. So if you look at all the sci-fi that was written in all the decades before, when they talked about artificial intelligence, they talked about this super crazy engineered thing, right? Think about like Data or Lore from Star Trek. Think about Isaac Asimov and then, the 3 laws of robotics and all of that stuff. Like all of that, we're saying how like precisely like we built the brain to be this way. Even that book, Damon, however you want to pronounce that, about the AI that was written not that long ago. I think it was 2013 when it was written. It still talked about heavily programmed logic-based AI. And now we're seeing that intelligence almost kind of emerges like we didn't build it, right? We created neural nets. We had this transformer architecture. Then we just like shove a bunch of data into it. and through this process of training it, something resembling intelligence emerges. Like we don't even fully understand how it works. So it's like similar to how you can grow mushrooms as long as you have the right condition, right? You can grow mushrooms. It's not like you engineer the mushrooms. They appear under the right circumstances, right? And you can have a highly advanced factory producing them, but you're not engineering the mushrooms, you're engineering the environment. And so I feel like it's the same thing here with these neural nets with artificial intelligence. We're engineering the environment to grow intelligence. We're not engineering the intelligence itself necessarily. I hope that makes sense. So Sahil P is saying Penrose's theory has to do with quantum coherence between neurons because of microtubules which interact with quantum mechanics directly. In my opinion, on our randomness comes from entropy of the universe. Yeah, so I do really want to do like a deep dive into understanding that. So I listened to, what's her name, Frau Hassenfelder, Sabine Hassenfelder. So she did a little bit of a deep dive into that and the microtubules and how they interact with like the quantum wave fields collapsing or something like that. So it sounds like most sort of quote unquote researchers that are, they maybe kind of like brush this off or they dismiss it. They're saying, here's the reasons why this can't exist. And it's unlikely that we have these quantum things happening in our brain that helps our brain calculate things or have consciousness or whatever. But it also seems to me like a lot of these like very serious, very smart people like Scott Aaronson, to me, I don't know, he seems like just like top of the line. Scott Aaronson, yeah. So like one of the smartest people, like certainly in that top sliver of 1% or whatever. Even he can probably build very strong sort of counter arguments against what Penrose is talking about, but still, even he's like, oh, but you know what? Yeah, there's something there. There might be something there that he kind of agrees with, and it's certainly interesting because it almost suggests that some part of our consciousness is immortal in a way. Like it's not just like if you just cremate somebody, like their brain's gone. This might almost suggest that there's something else that remains. And somebody said that Elon Musk said that I'm missing it. Either everything is conscious or nothing is. I'd be curious to know what that means. But yeah, that's a very, very fascinating topic of discussion. What is your timeline predictions for the 5 levels of AI? So third level is the innovator, right? So AI that's able to innovate and move science forward. So Gary Tan interviewed Sam Altman. So they're from the Y Combinator, YC. And so I think Sam Altman was the president of YC back in the days. Now Gary Tan took over, so they had an interview. And one of the things that Gary Tan brought up was when they had like a hackathon using GPT-4o to build stuff. One of the projects was they gave GPT-4o, I think it was, or maybe even one of the prior models, they gave it the task of optimizing airfoil. So kind of like airplanes' wings, like depending on the shape, they can be better optimized for airflow, for keeping the planes in the air. And they were saying that GPT-4o with some basic scaffolding took it from just like not working to competitive, which, I mean, to me, that's one example of a stage 3 innovator, an AI that is able to progress forward. I think we've seen the same thing with NVIDIA, Dr. Jim Fan, that whole Eureka thing, where GPT-4 was able to create better reward functions for training robots in the Isaac Gym and the simulation, right? They were able to get a robot, like a robotic hand, to twirl a pen. And what was completely mind-blowing to me was that it seemed like what they were saying is that as the complexity of the tasks gets harder and harder, human intelligence, so our ability to create these reward functions, to write the code to make the robot learn how to do something, our ability to do that like drops off, right? And these aren't just like everyday people. These are experts in machine learning. These are people that, code this stuff for a living. So these are not everyday people. These are like top tier people in that field. But at some point, their ability to write those reward functions drops off. So there's like a level where our intelligence kind of like is no longer sufficient. But GPT-4 was able to create novel solutions. So solutions that are different from human solutions that were better than us at creating these reward functions. So it's almost like, as an analogy, before we had steam power and electricity, humans, we can only build so much. We can carry so much. We only had so much sort of like muscle strength, biological strength to do stuff, right? And then we had the steam powered engines, and all of a sudden, like our strength like increased, right? So we could only go this far, and then, sort of artificial strength like took us to much further, right? So it almost feels like AI is going to be, we kind of passed the baton, right, to where we're like, all right, well, we got us here. AI, you figure out how to take us to the next step. So I feel like we're entering stage 3, or at least we have examples of stage 3 AIs. And I honestly, what was like stage 4 and 5? Okay, so 5 stages of development. All right, sorry about that. I just needed to do something really fast. Oh, sorry. Okay, so yeah, so I was saying stage 3 was innovators. I apologize. So no, so stage 3 is agents. Stage 4 is innovators. So that's what I was talking about. Stage 4 innovators. We're seeing examples of stage 4, and then stage 5 is kind of like they're able to run organizations. So complex sort of organizations where you need to be like managing all sorts of like different parts and pieces of it and stuff like that. So agents, I mean, we kind of know that agents are slowly entering the world. We're beginning to see them work. We also are beginning to see, the Zodiac is saying level 4 was innovator. Thank you. Yeah, I flipped that around. So yeah, so stage 3 agents, stage 4 innovator. So with agents, so Sam Altman's saying 2025 is going to be when that's going to be kind of entering the world. We saw Anthropic's computer use. And so that's the next step. So let's call agents, 2025, that's agents, the year 2025. Maybe the following year, we're going to be seeing more and more stage 4 innovators. Because again, I feel like we have examples of that somewhere, some things we can point to be like, this is a stage 4 AI. Level 5 was organizations. I don't know. I mean, it's moving so fast. At what point will we have this stuff managing complex organizations? I would not bet against seeing that within 5 years. Like if somebody said, do you want to bet that it's not going to happen within the next 5 years? Like I would not take that bet. I feel like we're going to see that. We're going to see at least examples of that. Pigeon saying, I think we will certainly get to level 5 by the end of 2025. That's crazy to think about. I think it's certainly possible, but crazy to think about. That's the thing. So in the New York Times interview, Sam Altman was saying how there's going to be potentially intense economic disruption coming from between the time when we get from AGI to like ASI. And certainly if you have level 4 and 5, that's closer to ASI. Certainly, it depends how you define super intelligence. But I mean, if it's running organizations, I feel like that's obviously a form of super intelligence. If it's better than human scientists at progressing science forward, then that's super intelligence. I think that's fair to say. So Sam was saying there's going to be intense economic disruption between AGI, and it seems like they've either hit it or we're coming close. Like we're there. So between AGI and ASI, it's going to be intense economic disruption. And so, he was being asked, well, who is going to solve that problem, right? So is the government going to solve that problem? And it seemed like, I don't know, it seemed like someone was like, oh, maybe not. But he's saying he believes that the researchers will solve the problem of the economic disruption. So what does that mean? Like UBI, everybody gets some sort of a payment every month for basic goods and services. To the people that haven't read, so Sam Altman wrote a great post called The Moore's Law for Everything, where he kind of outlines this idea. Like, imagine if the cost of most things that we need in life, healthcare and housing and food, etc., like what happens as AI takes over, robotics takes over. The biggest cost of most of the things that we consume is labor, human labor. So what happens when that gets replaced? We can expect prices for everything to start dropping. So imagine, prices for everything gets cut in half, let's say every 2 years, right? So if right now a house is $500,000, and next year it's 2 years later, it's $250,000, year after that, and it keeps getting cut in half. Same thing with your healthcare, same thing. So eventually your cost of survival is going to be very, very low. So it might not be that difficult to just like imagine if everybody needs $5,000 or $10,000 a year to survive, all the basic needs are covered. Could we provide enough credits for people to do that? So Pigeon's saying, I don't think UBI will be nearly enough. What do you think? Assuming that the prices drop, like Sam Altman described it in his post, like, because it's like we're thinking of current units of measurement, right? So it's like, yeah, I don't think we can possibly come up with enough money to pay for everybody's like everything. What happens if it's super cheap? Well, that's like a different sort of, that's a different question. So I think that's you got to look at both sides. Like it's like how much does it cost to keep a person alive and having everything that they need? I mean, like think about how much we spend on education, right? How much colleges cost, how much tutors cost. With AI, right, and that whole idea of Bloom's 2 sigma problem, right? So basically our school system is not very optimized for having kids learn. It's optimized more that we don't have that many teachers, we can't pay them too much. If kids have one-on-one tutoring, so if kids are able to learn at their own pace, called mastery learning, all of a sudden their school performance moves one standard deviation to the right. So it like drastically improves. And then if you add one-on-one tutoring, then it moves another standard deviation to the right. So you're basically taking most kids and you're turning them into like A+ students with 2 minor tweaks. The problem is we can't. That's not a realistic system, for most of human history, because we not every single person can have a one-on-one tutor and can go at their own pace. We need to shove everybody into classrooms on a quarter or a semester system. With AI, all of a sudden that changes, because all of a sudden, we could have one-on-one tutors for everybody, and I think that's potentially not that far away. So what is that going to do to the cost of education, right? So somebody mentioned Sam Altman saying, so Winsome Hacks is being sarcastic, saying Sam, too cheap to meter, intelligence too cheap to meter, Altman is $200 a month. The belief is that at some point everything will be how Sam Altman put it, like shockingly good models, and that intelligence will be like too cheap to matter. It's like negligible. So imagine in that situation, like the price of education just drops, disappears. You get world-class education that was not available to, that was previously available to only like the upper classes of society, available to everybody in every language in any place of the world, right? So that goes to zero, right? Healthcare, maybe that also goes to very, very low, maybe not zero, but it's like, peanuts. It's super cheap. Assuming we can figure out, so Google DeepMind Gnome, it's a material discovery platform, or a material discovery AI combined with robotics, where they test those materials out. So one of the things that they're hopeful for is, for example, building materials, right? If we're able to generate cheap building materials, robots constructing real estate, houses, etc., one of the biggest costs is the cost of living. What if we can like have robots build stuff anywhere for cheap? What I'm saying is UBI will work if everything costs, in real terms, and in real money, 1/1000th of what it does today. Because today we're wasting a lot of money just on inefficiency. So certainly, you know what I mean? So that's what I mean by UBI. Is it going to work right now? No way. Or I really don't think so. Sam Altman did a study on it. Seemed like it wasn't that positive. But UBI works for kids. If you got a young kid that needs to go to the arcade every once in a while, you give him $20 and he can buy some basic necessities. That works because there's just not that much that you need to cover the basic necessities. So that's kind of my thinking about it. I do wonder about what people are going to do. Like imagine not having to work for a living, not needing to worry about that stuff. What do you do? Is that a good thing? Like, just everybody is retired forever. Like, is that a good thing? Is that a bad thing? Most people will probably just go for, endless entertainment. One of the things that I wanted to talk about in one of the videos is the idea. Have you guys heard about the full dive VR? So the idea of kind of like the Matrix, plugging into a virtual reality with full senses, right? So you like the Matrix. If you've seen the movie Matrix, you're just plugged in. You think it's real. The first time I tried VR, I think we did the Vive headset. I went to my friend's house. I was blown away. I could not, because there was times when my brain had a hard time believing that stuff wasn't real. So to the people that haven't tried the super high-end VR, the thing to understand is like now with let me come back to that. So Rodrigo Gomez is saying, the way you put it seems what moves people is the struggle to just survive. Not necessarily. So, and that's an interesting point, because obviously a lot of stuff that we do is not just survival, right? There's creativity, there's ambition, there's all sorts of stuff. But I don't know, maybe different people will think differently about this. But to me, it seems like when you look at a lot of the people that have everything from the very beginning, that never have to worry about it, like, does that produce, if you're born into extreme, like billionaires, sons and daughters, kids of billionaires that don't really have to work, is that like the perfect human beings? And I apologize if any of you are billionaires. I have nothing, not saying anything bad, but it seems like the people that are at the very top and just have no sort of, no scarcity at all during their lives aren't necessarily like the most amazing people ever in general. You know what I mean? I mean, not applicable to everybody, but I feel like, some of the greatest people that I've met, the most, did something just crash? I'm getting a weird error message. Are you guys seeing and hearing everything okay? Yeah, so Doran saying they are not the happiest also. That's the thing. That's, I guess, is what I'm trying to say. It's weird to me that some of the sort of wealthiest young men and women that I've met in my life, people that were born into wealth, aren't the happiest. Like I've known some people that are extremely on the upper end of, sort of society in terms of wealth, in terms of how much money their families made. They have everything anybody could wish for. I'm not like, wow, they're just like perfectly happy and normal and, great mental health. Like, I would not describe them as such, So, and it's that whole idea that was brought up in the Matrix too, because if you recall, Agent Smith, right, he's saying like, we made a mistake. The first Matrix was a utopia. Everybody was happy. There was no strife. There was no scarcity. And you humans just hated it, right? You guys went crazy. So I don't know, like there's something to be said for scarcity, for stress, for striving, for, I don't know. What do you guys think about that? Am I crazy, or do you think that humans are on some level maybe a little bit hardwired to need a little bit of misery or something? So Dr. Joel Duff is saying need purpose. Purpose often is derived from challenges in our lives. I think that's well said, because the things that we miss as kids or adults, like the things that we lack, often become the things that we strive to avoid, right? So, if you have a parent that dies from a certain illness, you often hear the story of those people going into, maybe a profession where they can help, like a researcher or medical profession. So Tom Ross is saying it depends on parents. I think that if parents are able to create some artificial scarcity and create some sort of challenges in the kids' lives early on, then that is good. And maybe that's why we got to think about it. It's so funny. Okay, so who is the person that's the sort of the most well-known AI doomer? Eliezer Yudkowsky. So he's like very much against, he's very worried about AI, but there's this one sort of kind of tirade that he went on that was, I thought was very interesting, where he was saying like he was citing some paper or something that's saying that our happiness sort of set point is determined by either 4 years of age or 6 years of age, in terms of like what we perceive as our like everyday sort of scenario, our everyday, like how we are during those first 4 to 6 years of age determines what we think of as normal. And then if our life is better after that, like we are happier. And if it's worse after that, we're not as happy, because that's kind of like the set point. So he's saying like, if you want to have like the happiest kids, like what you got to do is for the first 4 years of their life, like put them in just like the harshest environments where like pterodactyls like swoop from the sky and try to like kill them, and they have to hide in underground bunkers and like live in fear all day, just surviving off of the rats they can catch and stuff. Like he just like described like the worst conditions of like survival, because then when they go into the real world, they're like, oh, there's no pterodactyls swooping down trying to kill me. That's incredible. Like imagine going outside every day and just being so grateful that there aren't these gigantic dinosaurs trying to kill you and swooping down from the sky and trying to eat you, and just being grateful for that every single time you go outside. It certainly makes sense that would make you a happy person, right? Or if you don't have to like chase and kill rats to sustain yourself, you can just go through a drive-through, you'd be happy about that. The Legends 007 saying, well, that theory is why he's an AI doomer. That's very well said. That's I feel like a lot of the AI doomers, they have to on some level there's got to be some like imbalance or some like mental health issues where if they weren't worried about AI, they'd be worried about something else. So it's not like this is the one thing that they're worried about. It's like their normal default state is that of worry, and just this is the thing that they're worried about now. And that's not to write off everything about AI safety and AI. I mean, there's certainly challenges and fears, and we got to be super careful. But just like when you listen to like the well-known sort of like the celebrity of the AI doomer world, like I don't know, do they strike you as just cool, chill people, like perfectly balanced? Let me know. I mean, to me, certainly they're probably highly intelligent. They're very smart, but they don't strike me as like just people that just like chill and enjoy life by default. You know what I mean? They seem like just a little bit, I don't know, neurotic maybe. Joseph Payton say, "Oof, this is getting clipped for sure." I gotta be careful about this. I haven't been on YouTube that long, to where I still gotta be. I don't think about stuff like this, but yeah, I could see how somebody could clip some stuff, take it out of context, and then blow it up on YouTube Shorts and TikTok, and then I'm like, no. I don't know how people deal with that actually. Connor is pretty rational. Connor, so he's the guy with the long hair, right? With the beautiful flowing blonde hair, right? That's Connor. If that's the guy, then yeah, I mean he's rational, he's smart. He is I mean, I don't like, he's kind of rude to people that he disagrees with. He kind of says these kind of like backbiting stuff, which I'm not a fan of. Like if you disagree with somebody, that's totally cool. You don't have to be a jerk about it. But if that's the person that I'm thinking of. But no, he seems like he will always choose the most pessimistic side. Like he's like, well, the universe is cold. Like just look at like all the stars and stuff like that. So it's just we're all gonna die, right? So it's just kind of like his thinking trends towards the negative. And certainly, I think in general. So are you guys familiar with the channel what was it, Healthy Gamer GG or whatever, where you have the psychologist that kind of explains a lot of the stuff that's happening behind the scenes. And I think he has some sort of training as, I don't know, an Indian monk or something like that. That's I think did a little bit of that. So he kind of like brings both those together. But it's like one of those things that he was saying is like smart people have a much harder time with depression because they're very smart and rational to the point where if their brain, if they're feeling bad, their brain is better capable of articulating why everything is so bad and everything's so horrible. So if you get a really smart person with, that's maybe a little bit like depressed or whatever, they will come up with like the most sort of articulate, rational, and incredible explanations for why they're right, why they should be depressed, and why that's the case. I mean, that's why you see, I don't know, whatever was it with Sylvia Plath or whatever, killing themselves and stuff like that. I probably shouldn't be talking about these subjects, but you know what I mean? That's just, I think at the higher IQ ranges, you can come up with better arguments for anything. And if you want to convince yourself that everything is horrible, you will be able to do that. And you will be able to do that very, very effectively. And you will probably beat people in arguments. Does that mean you're right? I don't know. Because Connor was arguing with Yasha Bach, who's another highly intelligent person, and who doesn't share his AI doomerism, right? So Yasha is talking more about, yes, like we have to be careful, we have to be, put a lot of like these safety guardrails in place, but, and he's talking about like international cooperation. And so like these are two very intelligent people, but one seems to be a little bit more neutral, right? To where he's like, well, it could go, here are the bad, here's the good, here's how it is. And I forget the guy's name, the guy with the long blonde hair. What did you call him? Somebody mentioned them earlier. It just seems like he just always defaults to the worst possible scenario. So smart people know more, and they just see more problems that they need to solve. That's the thing, is like, yeah, if you're, it's like a lot of this is probably like an evolutionary trait. Like the guy that just like back in our ancestors in the caves, right? The person that was like, yeah, everything's fine, just chill out. Like that's the guy that gets eaten. The guy's like, no, there's like a tiger in every bush. We got to be like anxious. And here's the 50 ways that I can see of us dying. That was an evolutionary advantage, right? So, yeah, certainly Connor Leahy. Let me see. Yes, so that's who I am thinking of, Connor. So this person on the left here, so that's Connor. And again, obviously very intelligent person, great arguments, all of that stuff. Just seems to me like it all comes from this. It starts out with the idea that everything's bad and there's like this threat, and then there's all the arguments are kind of built on top of that, and the arguments are very good. But I don't know. It doesn't seem to be very sort of like I would listen to Yasha Bach and Connor Leahy, like their discussion, because that to me, again, two incredibly intelligent people that know what they're talking about, right? Where you just kind of see in Yasha's case, I feel like he's open to the good and the bad, and he's willing to discuss the good and the bad, the good and the bad. And to me, I'd much rather someone like that is in charge of any policies, if we do any AI policies or anything like that, because that to me just seems a lot more, I don't know, rational, because we can't also just dismiss all the good stuff that AI can bring. I mean, we were talking about the longevity, escape velocity. Like, can you imagine if somebody that's assumes, right, somebody that has a, their P doom is 99.9999, right? They assume that the only way to stop the entire human race from being made extinct by AI is to have some sort of a global system of control of all the NVIDIA chips and all the compute. And that's the only way to move forward. Otherwise, just everybody dies, right? That doesn't seem to me like the right way forward, especially because, first of all, that erases all of the potential progress and all the good stuff that can happen. So I'd much rather have a person that's able to kind of see both sides and articulate both sides than somebody that's a little bit more like a hardliner about, no, it's all bad. So, and I did a survey on this channel where I was kind of asking people if they're more positive or more negative. I think I said, are you in general optimistic? Like throughout life, are you in generally an optimistic person? And are you optimistic about AI? And so I get the 4 quadrants or whatever. And so I think that what was interesting to me that more people are optimistic, both optimists and people that maybe in general are not that optimistic are in fact more optimistic because for AI progress. And a lot of the people that are AI doomers, first of all, they're I think a minority of voices, but they're very sort of like loud about their opinions, and they tend to say, like, they tend to reach for the top shelf with their predictions, right? Like they're saying, no, just like everybody's gonna die, and this is 99.999% certain. So I don't know. That to me, it's hard to kind of appreciate those arguments. Which is not to say that they're necessarily wrong, or it's not to say we should ignore AI safety. I feel like we need a more balanced approach. It's Hexen is saying doom, but I want it to happen. I like how you have the Quake 2 logo as your profile thing. So yeah, Time is saying, when does the OpenAI stream start? So we went. They already had that. Most people are not going to be too interested in, or at least for most people, this is not going to be what they've been waiting for. They had, how would you describe that? It was a way to fine-tune custom models. It's not something that I've really played around with too much. So, but there's another release that was released today that you guys might not know about. And that release was The Path of Exile. Let me see. So Path of Exile early access is available today. I think within the last hour or two, it went live. So I am going to stream a little bit of it. I know it's not AI related, but what do you guys think about that? Streaming video games every once in a while and talking about AI at the same time. It's hard for me to like talk for 2 hours straight. So having some sort of a content that that I can do without necessarily talking all the time would be great for live stream. Doran saying game stream when? Like now. Although you know what? So there's some issues with connecting. So just give me a second to figure this out. Because, yeah, PO2 looks amazing. Yeah, I've played Path of Exile, the first one, just a little bit. It was good. I think Diablo 4 was easy to get into. This sounds like it's a lot more in depth. You gotta it's just more, it's different. It's less arcade-ish. It's less fast paced. It's darker. Blood for the Blood God. All right. Since I started doing this, there might be some audio issues. So give me a second to figure that out. So I'm having a hard time getting into Path of Exile 2. I think because it got released, there's going to be a million people trying to join in. Sahil is saying, do you think we are headed towards a software Butlerian jihad from Dune? Yeah, so that whole idea of people really like rising up and not liking artificial intelligence, I think in Dune they said it was like one of the tenets of the faith in there, where it's like, thou shalt not build a mind resembling a human mind or something like that. I forget. But you know, we have been seeing like people already like attacking those cars, the Waymo cars in San Francisco. We are seeing protests against AI. And we haven't even seen, I mean, you know that the military is using more and more AI. A lot of these companies are joining and working closer with the US military. So we haven't even seen that shoe drop, and we haven't even seen the job displacement yet. So how many people, I feel like when that starts hitting, we might see a lot more people kind of rising up against it, which is sad, because I think that there's a lot of good, and I think it's up to us, the people that are kind of like doing this and talking about this, to maybe explain to people that what they want isn't a job, right? Like at the end of the day, is a job what you want more than anything else in life? Or do you want meaning? Do you want to be able to afford things, to provide for your family? Right? So people are we're conditioned that like what we want is jobs. At the end of the day, that's not the ultimate goal. So if we can like transition to, so we don't even know exactly how to transition past that, but if we can, that should be the goal, right? So I think the Path of Exile is slowly being downloaded in the background. In the meantime, here's Diablo 4. What's the deal with Elon Musk being insanely high in the Diablo leaderboards? Is that real? is that really happening? Or is that some, do you think somebody plays for him, or do you think he sits there grinding Diablo? Like, how many companies does he own? How many things does he do? It's bizarre. Yeah, in terms of job displacement, there was a study where they were seeing the tons of, for example, writing jobs on Upwork and Fiverr and stuff like that. Those are already gone. So it's already happening for a lot of stuff like that. And now I think some companies are using AI to monitor people better. Like there's not spyware, but whatever it's called, when the company actually pre-installs some sort of a spyware on their employees' computers at work. And so AI is, of course, going to make that a lot more effective, right? Because you don't have to, back in the days, you had to go through the footage, or, if it's like a keylogger, somebody had to look at it. With AI, it can like sort of go through it with vision, you know what I mean, and flag the stuff that the employee's doing that might be inappropriate or not work related. So you almost can have these AI agents just, like looking over your shoulder every second of every day, making sure you're not getting distracted. I mean, that's gonna suck. Oh, somebody's saying it became a thing during COVID. We didn't even have, so I think the pre-installation of the stuff on the computers probably really went through the roof during COVID. But now that it's in there, now that it's pre-installed with AI, it's going to be taken to a different level. It's going to get a lot worse. I got the $200 ChatGPT. We did a live stream yesterday testing it out. I probably should do a lot more. We didn't do any coding. It was very interesting how well it did solve some of the puzzles, especially where you have to kind of go back and forth and make sure that what you did was correct. So, for example, there's like a furniture placement problem where after you place the pieces, you have to go back and make sure that it sort of makes sense in the context of the question. And before that, the models just could not do it. And now, not only are they able to do it, but they're kind of seemingly really good at it. And the thing is, the whole Q star leak back in the days, that whole thing with what did Ilya see and stuff like that. I mean, I think the O1 Pro model that was just completely ungated, unrestricted in any way, like the true, full power final form O1 Pro model is what they saw. And that was the thing that kind of spooked everybody. Because I can see how something like that could be kind of crazy. I mean, if it's doing the math Olympiad problems effectively, right? And that's what they were saying about it at the time, that it's really good at math. And I mean, think about how quickly that progress, and that was a year ago, actually probably a little bit more than a year ago. So think about how quickly the insiders at OpenAI saw that progress, right? So they went from, GPT 3.5, then 4, and 4 was a big deal. And then the O1, the Q Star or Strawberry or O1, whatever you want to call it. And keep in mind that whatever they have behind the scenes isn't what you and I are using. Even the $200 a month, that's not the powerful thing that they have, the ungated thing that they have. That's the corporate version of it that they release to the public. That's gated. That's lobotomized to not say anything bad, etc. So I can definitely see how that could have quite an impact. Seeing that much progress take place in a year, and then just going, all right, like nothing's stopping this train, and I don't know if we're ready. So that's the thing, is like looking at what OpenAI is releasing is like looking at the distant galaxies. Like what we see happened a long time ago, because what we're seeing right now with the $200 a month model is what they were freaking out about before November of last year. So can the O1 be kind of like the semi-AGI? So yeah, Microsoft, when GPT-4 was released, they referred to GPT-4 as proto-AGI, which certainly makes sense because it had what appeared to be, general intelligence. It can do a lot of stuff well. And now we're sort of getting closer and closer to that with these models. And like Sam Altman was saying, like it's going to be like a mile marker along the road. So it's going to be like something that we pass. There's not going to be necessarily like a huge sign that we've achieved AGI. Like we're slowly gonna pass it. And I think Ethan Malik, one of the great follow on Twitter, so he did the post saying like the jagged frontier of AI intelligence, because some things it obviously does better than humans already, right? So it's superhuman in certain things. Like for example, for brainstorming various things, ChatGPT is far, far, far superior to humans. They tested against like coming up with ideas versus a classroom full of MBAs, for example, and ChatGPT beats them. It comes up with more diverse ideas, faster, unlimited amount of them. It might be worse at some things, like certain reasoning tasks. It might be still not very good at, but it's getting better at math. It's going to be getting better at coding, at least the sort of simpler stuff. So it's like you're always going to be able to point to certain things where it's worse than humans and certain things where it's better than humans. So at what point do you say it's AGI when it's not, there's nothing that it's worse at? I feel like we're entering AGI now, and just I think it was Gary Tan from Y Combinator that said like, or no, I don't think it was him, but they were saying like at the point that like we're arguing whether or not we have AGI, that's when AGI will be achieved, right? Because it's like a year ago we weren't arguing if this was AGI or not. We're like, okay, we're not there yet. And I feel like with this model, and over the next year or two, more and more people are be saying like, hey, yeah, we're close. We're entering the era of AGI. At which point you can kind of start assuming that, okay, like we're kind of there. Oh, one is already AGI. It's better than most people at most tasks. Yeah, I think a lot of the stuff now is kind of like the scaffolding for it, if that makes sense. Because the thing is, if you can explain what you want to do, it's gonna do it better than most people. You know, I mean, depending on what you're asking to do, but there's tons of stuff that it's better at. So now it's more about how do you sort of, it's the agentic quality of it, right? So if you're able to create some sort of a scaffolding around it so that it can keep going and keep executing and keep refining its approach, and like that's when it's going to get a little bit crazy. That's when it's going to be hard to say that it's not AGI. And the other founder of Google DeepMind, Mustafa Suleyman, so he was saying how what we're going to be seeing is almost going to be like a new digital species that gets released onto the internet, these AI agents. I haven't seen that interview yet, but he had an interview with the guy from the Rundown, AI Rundown. So yeah, I got to check that one out. That might be interesting. User 420, thank you for the super chat. Are you pro longevity? Yes, certainly the idea of kind of getting old and decrepit, if we can get rid of that, there's tons of good stuff for that, in a sense that, you know, first of all, it's going to cost a lot. It takes less money to take care of healthy people than it does of, you know, sick people. If people get old and sick, a lot of our sort of resources go to that just to manage the suffering too. Like, if we don't have to have that, then we should certainly, if we can fix it, we should certainly fix it. So what's the downside of longevity? You mean like from a population control sort of perspective, like we're going to have too many people? The thing is, it does seem like people have less kids the more chill their life is and the more sort of economic security they have. You know what I mean? Like once a country gets developed, the fertility rate kind of starts dropping. So I feel like, and that also has to do with, like, you know, kids not dying young. So based and a life build. Thank you. Yeah. Well, yeah, I'm totally on board, and certainly, I mean, yes, I'm 100% for longevity. Some people bring up the idea of, you know, overpopulation, stuff like that, and certainly that's stuff that we got to deal with, stuff that we got to talk about. But that's a separate issue. Like, I wouldn't say, it's strange to me that people would be against longevity because they're worried about overpopulation. That doesn't make sense to me. It's like, yeah, let's keep suffering, let's keep dying younger than we need to, so that we, because of this potential fear in the future. No, that doesn't make sense. If you think about it, most of our life getting better throughout the ages is due to technology, right? Some sort of progress. That's due to, you know, a few smart people working very, very hard to create new things. And it's strange to me that now we've reached a point where some people are now like almost like wanting to go back and like, no, technology is bad. We need depopulation. We need, you know, less technology. And like, it's so bizarre. It seems like it's like a kind of going back to the dark ages almost. I think the path forward is through progress, is through better technology, and allowing the smartest people in the population, the geniuses and the, you know, the people with special abilities to do their thing, right? Because if they can come up with a cure for cancer or some new drug or whatever, we're able to like, write that information down. Now the entire sort of human race has access to that, right? So when they, discovered penicillin or whatever, now we all now know about it, right? And that's adding value to everybody. I don't know. Let geniuses propagate uncontrollably. I like that. I like that. The other interesting thing is that we haven't talked about is like what happens. Is it possible that with genetic sequencing and genetic editing, could we create smarter humans, right? Could we just increase the average IQ of people, right? What kind of effect does that have, I wonder, on the world over a long enough period of time? Like, if everyone's smarter on average. Is this Path of Exile? No, this is Diablo 4. Path of Exile is... Give me 1 second. Let me see what's happening. Yeah, so I think tons of people are trying to get into PoE, Path of Exile 2 right now. So still waiting for that to happen. This is Diablo 4. Which I really enjoyed Diablo 4, but you hit a certain point when you're just like, you get to the end game, you're kind of grinding up the various whatever torment difficulties or whatever. And it's at some point it gets a little bit stale, a little bit boring, I guess, because you're kind of doing the same thing. I gotta say the storyline was pretty cool, and how they portrayed everything is just it's pretty dark. Which always was Diablo's kind of claim to fame from the very beginning. I mean, it was a very dark game compared to what was out there, especially initially, and then kind of like more and more games started producing stuff like that. So it's not as much of a big deal anymore, because I think Path of Exile, like the first one I played, I was like, wow, they really stepped it up a notch in terms of just like how like dark stuff was. Because so there was who was the guy, hardcore history, Dan Carl no Dan who was the podcast host of Hardcore History? Used to be, and it probably still is, I haven't listened to it for a while. Great podcast about history. His whole thing about Dan Carlin? No. Dan something. His whole thing about World War I and how that started was incredible. And so one of the things that he did was about painfotainment. And it's like the history of torture throughout, the history of the world, and how it kind of evolved. That was hard to listen to. I gotta say, that was rough. But one of the things that he talked about was the wheel, and I'm not gonna go into exactly what that was, but it was like a medieval torture device. And when you start Path of Exile 1, I think like the first area or like the second area, like very start near the start of the game, the thing that you get attacked by, Dan Carlin, thank you, Dan Carlin. The thing you get attacked on are these rolling wheels with the victims attached to it that they have come back to life, and it was disturbing because I had just finished listening to how that worked and how like insanely gruesome that whole and then like I think within 2 weeks after that I'm playing a game where they use that as like the thing that attacks you en masse, and that was incredibly disturbing. But yeah, I don't think Diablo would ever kind of go there. Because they're more corporate now. Blizzard is more corporate. They probably don't want to do. I feel like that's crossing a line, right? There's certain things where it's like too much. Watch out for the Hummer. Is that from Battle Bit? Yeah, I I think there was one where I like dodged it perfectly and I was able to shoot the driver, and then the other one I just got rammed without realizing it was coming for me. So, all right, let me check on Path of Exile. All right, so I'm not sure what's happening with Path of Exile. I think I need to. I think it's just since it's early access. I think way too many people are trying to log in right now. What I think I'm going to do is I'm going to take a break and have some food and just chill for a bit. If I can get Path of Exile up and running, I'm going to start another stream and maybe just do that for an hour or so, depending on what time of the day that's going to be. But I hope everyone enjoyed today's stream. I had a great time kind of going back and forth and talking to you. It's incredible how much knowledge there is in the chat. I'm so happy that people brought up Penrose and Scott Aronson and all of this stuff that I don't really get to talk about too much because it's not directly AI related. I mean, Scott Aronson was on OpenAI's safety team for a little bit, or some, yeah, I think it was the safety team that he was on. He was moonlighting at OpenAI, as he said. But absolutely incredible. I just really, really, really enjoying these. I'm hoping to do a lot more of them. I hope you guys are enjoying them as well. I'll try to maybe at some point even have like a set schedule when I go live so that it's not just like random. Now I'm kind of piggybacking off of OpenAI's streams, but yeah, but it's absolutely loving these interactions. So thank you so much. Sorry if I missed your comments or and stuff like that. It kind of goes pretty fast, so I try to focus on what kind of jumps out at me, but I'm not going to get to everybody. So thank you so much. So Vintage US Tech, thank you for giving a thumbs up, a like if you guys can do that. That helps. But either way, Absolutely incredible. Thank you so much. And I will talk to all of you soon. Have a great day. See you later.